The way I've described it is modern GIS is the process, systems, and technology used to derive insights from geospatial data. Modern GIS uses open, interoperable, standards-based technology, can be run locally or in the cloud, and scale to work with many different types, velocities, and scales of data.
Welcome to another episode of the Mapscaping podcast. My name is Daniel and this is a podcast for the geospatial community. So my guest on the show today is Matt Forrest. Matt is the VP of Solutions Engineering at a company called Kato, and today on the podcast we're talking about modern GIS. So some of you are going to listen to this episode and be tempted to think, oh, modern GIS, that's not what I'm doing. Am I wrong? And the answer is no. Do not confuse modern with the idea of right. So modern is not the same as right in every situation. And modern does not mean only this is the only way of doing something. This is simply Matt's take on what he sees modern GIS might look like, not the best or the only way of doing GIS. This podcast is sponsored in part by Lightbox. So you can find Lightbox at lightboxre.com. And what do they do? Well, Lightbox is a data platform. And it's an authoritative source of North American real estate and location intelligence data. So you're probably wondering what kind of data are they an authoritative source of? So they have parcels, building footprints, administrative boundaries, census data, schools, demographics for neighborhoods, points of interest, school ratings, traffic volume for neighborhoods. As far as the property side of things goes, they have ownership information, loan and sales transactions, contacts and mailing addresses, historical aerial photography. So you can use the Lightbox platform to do your analysis in the platform itself, or there's a set of APIs that you can use to get a hold of the data that way and perhaps build your own analysis around it, or you can bulk download these data sets as files. If you're looking for a real estate information and technology platform, check out Lightbox. I'll put a link in the show notes to make it a little bit easier for you to find. Thanks, Lightbox. Really appreciate your support. Hey, Matt. Welcome to the podcast. I'm really glad this has worked out. I'm excited to talk to you today. You are the VP of Solutions Engineering at a company called Kato, and I'm going to ask you to explain exactly what that title means in just a second. But I think before we get there, would you mind just introducing yourself to the listeners, please? Perhaps explaining who you are, what you do, and how you got involved in geospatial?
Yeah, absolutely. And thank you for having me here. It's kind of surreal having listened to your podcast so many times and now being able to be here. It's really exciting and happy to carry on the conversation. So you introduced myself and what I do. And my journey in geospatial started in college, like many folks. I didn't exactly know what I wanted to do right out of the gate in terms of majoring. Someone suggested I go down to the geography department, and I fell in love with it, really enjoyed it. Took more of a, human geography, cartography, and some of the GIS coursework. So it was a little bit of a mix, but I knew I loved working with geospatial data, creating maps and visualizations, analysis. And when I left, I wanted to continue to do that. And I did some of those projects on my own throughout the years. But when I moved to New York City in 2012, I met someone named Javier de la Torre, who's the co-founder of Cardo. And, we started working on some things together. I was using the tool called Cardo DB at the time. And in 2015, made the jump to join and have been there ever since. That's sort of been my story. I've been using different geospatial tech throughout my career, always focused on solving problems, working on different analyses, hearing from the people that we work with at Cardo and others how to solve different problems. And that really kind of sums it up. So whatever is needed to, from a technology perspective, bring together and solve these problems and find creative ways and different tools, that's sort of been the storyline of what I do. So it's been a mix of using lots of different technology and in different and creative ways. So it's been a really fun journey for me to do all that and use so many different tools. I mean, that's the part I really enjoy about it is I'm always learning both from the people that we work with and solving new problems, but also, great ways to solve these problems. So
It sounds like you've come a long way in your journey. So when I heard you talk about university, about college, I heard human geography and cartography, making maps, and now you're the VP of Solutions Engineering, and you're talking about tools and technology. How did you make that leap? That feels like a long jump from making maps. I understand there's a lot of technology involved in making maps, but when you were talking about it, I had a feeling it was more the visualization of data. Am I on the wrong track there?
No, and that's where it started. I was really focused in the visual aspect and the design piece, but you were always using the different technology, and I was able to take some web mapping courses at the time. In 2010, they were taught in Flash.
Wow.
So the only practical coding or program experience I left college with was in ActionScript, believe it or not. So, I kind of left there and was seeing, a lot of different things happening. Google mashups, people were building maps with JavaScript. D3 was really kind of starting to come into its own. So lots of really cool things happening, but it always felt like a little bit of a reach away. And I started to also kind of dip my toes into the open source space using QGIS. The first time I downloaded it, I think it was from some random blog website. It was a very, weird experience downloading it, not like you have today where it's everything's in one place. So, I was using all these tools and figuring it out. And, over time, I started to try and teach myself bits and pieces of these things, never going kind of all in, right? And really diving into it. But Cardo really gave me a space to do that. But what I love about it is that, it's its own tool, but it uses these core foundational open source technologies. And that's been sort of a hallmark of everything we've done from the, CartoDB days using PostGIS, import tools using GDAL, great front end libraries with Leaflet and now DeckGL. So it's always been a part of the product and a part of the process. And at that point in time, I was like, well, I can either kind of sit and understand these things or really dive into it. And I didn't have a roadmap. I just started trying to dive in and learn that. So, I started learning JavaScript, and that led me to React, eventually leading me to data science and Python and machine learning, and then eventually into data engineering. And all through that, since we're so, foundational in spatial SQL and PostGIS, I was learning a lot of SQL as well. So that became, my go-to for analysis, because eventually it was easier to type out a query and get what I wanted out of it rather than, do some different things. So that's my journey, but it was very much a winding road, to get there. And why, I've started to put these things out there. As I said, it was a tricky journey for me. I've had to piece it together, and I've learned a lot of things along the way, both what helps and maybe more so what isn't as successful when you're learning these concepts. So I just try to put that out there and share that. But the other piece and kind of the topic we're talking about today is I always never knew what I did is the best way to put it. And I know GIS and broadly, but I didn't feel like I was doing the same thing as many folks in the GIS space. I wasn't doing development, I was doing analysis. Was it some spatial data science? Sure. But there's always this kind of middle ground of what am I actually doing and how do I describe it? And that's sort of what I started to try to formulate is like what is that? And that's sort of what I landed on this modern GIS. It's GIS and it's analysis, it's using data, it's moving and manipulating data, creating outcomes and outputs. But it was different in a way. So I was trying to kind of in an effort to give myself, a definition around that, but hopefully others can kind of recognize and formulate around that too. So that was sort of the effort around that.
So I just want to catch the listeners up. So you're talking about putting things out there and sharing your work, sharing your journey, which I greatly appreciate, by the way. And what you've been doing lately, or what I've seen you do lately, is creating these actually really awesome articles and posting them on LinkedIn. And the one that really caught my eye was an article about what is modern GIS. And just this term, modern GIS, caught my eye. I read the article, I thought it was brilliant. And that's what I really want to talk with you about today. So, but can we just start with some definitions? You were talking about how do I describe what I do before. This is, every GIS person, every geospatial person has said something to do with Google Maps and some data and so, sort of cobbled together these statements that don't really go anywhere. People look blankly at us and then they go away. So when you think about GIS, what is GIS to you? How do you describe it today?
Yeah. So when I look at modern GIS, and this is an effort to summarize the way I feel about how I'm interacting with geospatial data and tools, I'll just give it verbatim because I tried to be purposeful in the terms and the words and all these different things because I felt that was important. But the way I've described it is modern GIS is the process, systems, and technology used to derive insights from geospatial data. Modern GIS uses open, interoperable, and standards-based technology, can be run locally or in the cloud, and scale to work with many different types, velocities, and scales of data. So some key points in there. It's the tools and technology. I think there's a broader practice of the people, the ways and the methods and the interactions you have. And when you say geospatial, I think that's something maybe even larger. There's geospatial ecosystem and community and all these different parts of that. When we talk specifically about the tools, right, that you use, I think that is what GIS is, a geographic information system, right? But where modern GIS can slightly differ is the open concept, interoperability, standards-based technology, and then the ability to that anybody can run this, no matter if you're on your machine and you have no internet connectivity, or if you're running this in massive workflows in the cloud. It works at any scale, right? So it's completely, scalable to move. I'm running a notebook or a Jupyter notebook locally with GeoPandas and creating some analysis. And should I need to suddenly scale that, use a data warehouse or run that process in the cloud and throw lots of CPUs behind it, you can do that. So it can scale all of those different ways. And those were some of the key principles I've tried to call out with that. And that's kind of how I summed it up. So that's the way I see it. And the key is probably the most important part is like, what do you do? It's the deriving insights from geospatial data. I'm using this data to tell a story, solve a problem, help someone. That's all ultimately, I think, what we do. So
I do absolutely agree with that. So a couple of things in your definition stand out for me: open, interoperable standards, and obviously this cloud-based technology, so scalable technologies, data at different velocities and scales, and being able to deal with that. Can we have one without the other? Can we have a scalable system that can deal with different data types and velocities and scale without having open standards? Like, are they interconnected?
well, not always. I think they're pretty close. I haven't come across like a closed source system that has that scalability, right? Now there are commercial tools, data warehouses and others that reach that scale. And some of them have some proponents that are, what you would traditionally call closed source. But a lot of them use open source technologies under the hood. I mean, they're using SQL in terms of the language to interact with them. For example, Databricks uses Spark and can scale very rapidly that way. So at the core, they're all using some of those technologies. And I think that's where we have some of the best technology is in those open tools and toolkits that can help you scale and grow. And that's all the efforts I've seen around that. When these things are out in the open, people can work with them across teams and across technologies and across teams. I think that's what I'm trying to capture with the interoperability part is that you can move from different locations or databases or toolkits, but the languages are common. Using Python, SQL, these standards, open-based documented languages, not something that might be more proprietary or something like that, to connect to systems that are largely open and scalable. So I think it's certainly possible, but I don't see the broader technology space moving that way. I actually see it running more towards the open route. Many of the clouds are built on that tenet of using very good open source technology, but handling the infrastructure part for you, right? You're not the one who has to maintain the machines or the databases or the backups or any of those things, which is the really big complex part. If you're sort of working in the IT or management, or if you're a DBA, you'll know all about that. But they help you do that and then just use these open toolkits, which I think is the right way to go. So it could be, but I don't see it happening.
Paul Ramsey opened my eyes to this. He said that the cloud couldn't exist without open source technology. And I think his argument for that was something along the lines of, if you had to pay for every instance of GDAL that you spun up, that Planet was using, for example, to process their terabytes of data that they're collecting, on a daily, weekly basis kind of thing, the business model would die. There is no business model because you couldn't do it right. But because GDAL for every instance you spin up, it's free essentially because it's open source. And so his argument that the cloud simply couldn't or wouldn't work from a business standpoint without these open source technologies. Would you agree with that?
100%. I think that when you look at all well, I mean, and this goes across everything in the cloud really, is that the core technology these teams are using to build on is open source. And when you look at all the times, I mean, if you're running these processes in scale and with massive amounts of computational power, they're all built on these great foundational open source tools. So without those, it becomes very hard to succeed and grow because it's just there. And that's what I think the power of it is. What I think is most important about modern GIS is that anyone can do it. Yes, it's ready for the cloud, but if you want to do this locally on your machine and start today, there's nothing stopping you. And I think that that's a really powerful statement is, that anyone, anywhere can start doing this. And now the challenge here is in the learning paths and learning that information. But I think it's incredibly powerful that it can go from one computer up to I'm running this on serverless processes and hundreds of nodes and scale and I think that's just a really powerful transformative concept that the core technology there is scales across that. So I do agree with that. That I think open technology makes the cloud possible, and I think it makes the possibilities very interesting, especially in the geospace, because there is such an amazing open source community that's developing and building and collaborating, discussing these things, and it has for years. From GL to PostGIS, DeckGL is a project we've worked quite a bit on developing spatial indices like H3 cells, and quad keys, tiling systems, creating tiles with Tippecanoe and how can we scale that? And that's something we use in Cardo in our products is to how do we use open technology to scale that and grow quite a bit, all the way up to these data engineering workflows. We've been using different tools like Apache Airflow and Apache Beam. That's maybe not traditionally in the geospace, but has helped us scale our work with, once again, those same open source tools. So I think it's incredibly important.
So we're talking about scalability and how open source tools, open source technologies enable this, and how they're a really integral part of what we think of modern GIS. When I think of modern GIS as well, I think about remember all those hassles you were talking about at the start when your first time you downloaded QGIS and it was split in different pieces and you had to get it from some random website. I think of the user experience being much smoother as well. I think this is an expectation of modern GIS, and I noticed when you're talking about scaling, one of the things that you said and were obviously quite excited about was this idea that anyone can do it. So you can download something, you can work on your local machine, and then very quickly have this thing running, in a massively parallel environment. But it's that user experience, that ease of use that I think, and I think our expectations when we think about modern GIS are massive compared to what they were like 5, 10 years ago when I was learning GIS, perhaps when you were learning GIS as well. Would you agree with any of that?
Yeah, it's changed significantly just in terms of the ease of access. I think spatial data science and this data science wave, even generally outside of geospatial or GIS, has really, I think, propelled people to start to explore these tools, but also created a whole industry that's built around making these tools more accessible. So there's lots of maybe a few years ago starting up a Jupyter Notebook server and downloading it, and you can still, of course, do that today, but might have been a bit more daunting. But now there's so many great tutorials on it and services you can just start with. I mean, anyone can use Google Collaboratory and just start with a notebook and start writing Python. It's become just so much more accessible, and the tools to access that, and then the supportive network of content and tutorials and guides has also improved greatly. Where I think there's a lot of where there is room for improvement is around community collaboration. I think helping others. I talk to a lot of people who are kind of like, how do I get started on this? I'm like, I think there's such room for people to be talking across many different geographies and locations and backgrounds to learn from each other and progress their career paths together. And I think also, how do we create tangible learning paths, that are really viable to help people grow? This, like I said, I walked out of school with learning ActionScript and some HTML and CSS. So could I program? I guess you could say so, but there was no clear like, okay, do A, B, C, and D, and then you'll have these skills, right? That's one challenge, and I think the even bigger challenge beyond that is everything. If you look at some spatial data science roles or GIS analysts, they have this full list of things you should know that include everything from data science, spatial data science, to data engineering, to analytics, toolkits, to database administration, there's this whole mix of skills that you're kind of expected to have. So can we segment out career paths and learnings and specializations, within this space? I think that's also something that we're starting to see, but I think continue to see as well.
I'm really glad you brought that up about career paths because when you're talking about those learning paths, I can definitely see it. It's daunting right from the word go. So I'm looking through your article right now, and I can see you've mentioned I'm only three quarters of the way down the page, and I can see 15, 20 different technologies that you've mentioned. It'd be incredibly daunting for someone just starting out. So definitely interested to hear thoughts, or I guess interested to see how we're going to cope with creating those learning paths and how they're going to lead on to career paths. Because, like you said, you had a winding road to get to where you are today. But I think in the future, people are going to want to see a much more structured path. If they're going to invest a lot of time in learning these things and becoming experts, like we hope they do, they're going to want to see, okay, well, where can this take me? And at the moment, I don't think it's that clear for a lot of people.
No, I think there's a lot of new paths that are opening up. So talking about the post, I think one of the core principles of modern GIS is that it will support new job functions and new roles. Now that's growing. It's starting. And I pulled some very unscientific data from the LinkedIn search and put in the post, but I still think a lot of people are geospatial or GIS analysts. I think that's kind of a overarching term in the space. So what I pulled is that there's about 5,100 people doing that type of work, geospatial or GIS analysts. Now, when you look at geospatial or spatial data scientists, there's about 300 roles, and this is just there might be more, but this is based on what I can see on my search. But then geospatial data engineer is about 100. Geospatial developer is about 350. And geospatial architects about 150. Now, I think if I listed off any of those after geospatial analyst and you're, maybe a GIS analyst or starting in the career path, or you might hear things like, I think that's kind of what I do. I map more to what a data engineer is, but there's nothing out there that says these are the skills or these are the key areas to focus on. And that's one thing that I think is something that is incredibly important. Geospatial data engineering with the explosion of data that's out there and figuring out the best ways and practices to make that really useful is very important. Critically important because it can save time and save cost if you're doing massive scale on the cloud. That's something we've been doing quite a bit of, is to say, can we actually use spatial indices like H3 and in ways for when we're talking about terabytes of raster data that's being updated so frequently, can we use that to actually, in a way, eliminate the need for the geometry in the data warehouse and render and query and visualize faster? And the results we've seen are tremendous, both in terms of rendering speed, query speed, and things like that. So that process is only can happen when you have good data engineering principles. And the other concept that's really difficult here is that data engineering in itself is a massive field. So, you need to know the geospatial pieces to it, but you also need to have some of this foundational data engineering pieces. So is it possible to have all of these different things? I think that's a impossible task. You have to, so, maybe not impossible, but it's daunting, right? So how do we lay out these very clear choices and says, if you're going down data engineering, this interests you, focus on these areas, learn this, then you can go deep as you start to progress. But you also, I think, set yourself up to be in a really unique position, because if you say I'm a geospatial data engineer, there's not many of those out there, but there's lots of organizations that are going to have these challenges and currently have them. So you put yourself in a really unique position to say, not only do I have the geospatial expertise, but I have this incredibly deep data engineering expertise. And that applies to any of these other fields. You're unique if you're a geospatial developer, an applications developer. So I think that's important to call out. I think there's ideas and discussions about this, but how do we codify that, make that easier for people to understand where they should go and what they should learn, and then get those into different education paths, using existing resources or new resources to help people understand that. But I think modern GIS and the technology supports that and helps that grow. So
So one thing I noticed about your post, you've got this image there where it says top geospatial jobs and skills. And of course, this is the data you've pulled out of LinkedIn that you were referring to before. If we think about the skills here, on the skill side, I can see PostGIS, 31,000 people, Leaflet, 64,000 people, QGIS, 150,000 people, GeoPandas, 3,100, and GDAL, 4,900. Do you think those are just the skills that people have, or do you think that are they the skills that are representative of what the market is asking for?
I think they're definitely representative of what the market is asking for. And I've kind of talked about this as a concept. If you're trying to figure out, okay, modern GIS, it sounds interesting. Where should I go? Right. And it kind of maps to this in terms of an order here, in a way. I always say if you're just breaking into this, start with QGIS because it's desktop, it's easy to start with. There's not you don't have to do a lot of command line downloads, but you can break into, and stand up a database and connect that and still have a familiar GUI to interact with. You can run Python in simple ways. It installs GDAL for you, and you can see exactly where that's happening. If you're vectorizing a raster file, you can actually, it spits out the command and shows you exactly what it's doing. So it's kind of just walking you through that, which I think is incredibly valuable. Now, that's something I've learned along the way, but I don't think anyone said, here's why you should start here, and here's what you can learn from that. But as you start to go, I've sort of talked about a crawl, walk, run, and sprint process. Starting with QGIS is your crawl. The next is I say go into Python and GeoPandas. GeoPandas is basically your Python toolkit for a lot of the same things you can do in QGIS. Your intersections, your clipping, your centroids, and all those things will feel familiar. And you can start to add those Python concepts into it. And you're also using a very common data format, which is the data frame. It's a geo data frame, but you can easily start to work in pandas skills and some of those other top skills that the data Python data analysts or the data scientists are using. And if you want to go deeper on spatial data science, you have the Python background now too. The next piece is actually going into the run would be SQL because you can take a lot of those processes and make them a lot faster on a database. Your podcast with Paul Ramsey about PostGIS saying that, I think he said that, when you run these things on the database, you're closer to the data. It makes it much faster. And, that you're right there. It's, the core language is sort of a, lower level. So, even if you're running and connecting to that through Python, you're always somehow going back to the database. So the more you can learn there helps you scale and run. And then the last piece would be the sprint, which is the cloud, because then you can learn how to scale these things on a massive scale. So I really feel that these are representative skills, in terms of what different job creators are sort of looking for.
It's interesting, like that you focus on QGIS. I mean, I understand why you do it, but in this context of a modern scalable GIS system, a desktop program feels kind of old-fashioned, doesn't it?
It does. That's maybe the odd part, right? Because it's sort of a nice entry point, right? It's a soft landing, if especially if you're coming from other desktop tools or that's what you've learned, and which is what I learned in school. I learned on desktop GIS, so I was very that's what I was taught. That's how I learned, and so it's very easy to start to go there. But then you have all these easy options to start to build into that, right? So it is kind of an odd space to land, but I think in a way, even within that, Q does present an amazing portal to connect to all these other concepts. Like I said, you can run this locally and on your machine. QGIS does that, brings in all these foundational elements. You can, if you want to download QGIS and start running GDAL commands, guess what? You can. If you're on a Mac, it's very easy to stand up a PostGIS database with, as a Postgres.app. You can just start loading data in, connect it to QGIS. You can even connect your other cloud, databases or data warehouses and things like that. So it's sort of this, in a way, soft landing and entry point, and it can become a command center. So I think it is a very good way to start there. But yes, it feels backwards to say, well, why are you starting with this desktop system? But I think it's a good way to begin.
And I think you hit the nail on the head there when you talked about how the QGIS could also just, instead of being seen as the entire stack, it could just be a piece of the stack where you're interacting with these different technologies, where you're pulling data from different places. And this leads on really nicely to this. I think it was one of your last points about what defines a modern GIS system. Your last point is outputs of many types. Could you walk us through what you mean by that, please?
Yeah, there's no wrong deliverable in modern GIS. There's no one thing that says when you are working through modern GIS, you create blank, whether that's a map or anything. I think there's so many different outcomes that are developed, and that allows you so much flexibility to create what you need to solve the problem. And going back to the definition, we're solving analysis and complex problems with geospatial data. How we do that can look many different ways. So that could be a dashboard, that could be a notebook you're delivering for someone else to run. You can build APIs and microservices. Maybe that's a data pipeline to do some of the complex data engineering. Could be a full stack application, mobile application, tools for data collection, machine learning model, static maps, reports. It doesn't matter. And I think that's really a core tenet of modern GS is just the flexibility. You'll walk away with the tools to build what you need to solve the problems, no matter what the problem is. And that's something that we've consistently seen is that sometimes you just need an API that someone can connect to a developer in another system that's non-geospatial and say, I can just call out to that, put in my parameters and plug it into that application. But that those few data points that might come from that API are incredibly valuable for them to, help solve problems or fix an outage in a cell phone tower, or ultimately help get your truck to the right delivery point, or provide a public service. That little bit of information can go a very long way. You're not constrained by what you're delivering, and that should be a very freeing concept. I think it's very fun to say, I can kind of come up with something in my mind and build it and go from there. So I think it's, like I said, it's a core principle. So
I think it is a very freeing concept, like the flexibility that you have, and not just sort of locked into like the output is always a map. So yeah, I appreciate what you're saying there. I also think it comes with the burden of education, because I think if you have been, for example, going around your organization saying, "I'm the map guy," I do GIS, I do Google Maps. It's kind of like that, just a little bit more technical. If you've been selling yourself in that way, then you've got a real burden of education to teach people. Well, I also do dashboards. This could be an API. We could make a data pipeline here. This could be a simple application. This could be something else entirely. It doesn't always have to be a static map. When you think about industry, do you see people understanding that all of this is possible, or do you see people still wanting a map?
a lot of times it starts with the map. So the map becomes an entry point, right? I think in geospatial is naturally visual. So that's certainly not going to change. But I think visualization is so important to the way we communicate geospatial data and geospatial analysis. So I don't see that changing, but I think you can also start to weave into that what are some of the other pieces that are happening in the visualization. So start there because people naturally understand that. And I think maps, we all get into maps and geospatial because maps are, we enjoy them and we think they're cool. But explain what's going on. If you say, like, what's happening here is that within this polygon, I'm intersecting and counting using spatial relationships on a database to, figure out what's within these areas and aggregate them. And that can be surfaced many ways. If, it's not just this map that needs to be the output. If I need to connect to a business system or a tool or something else, we can do that as well. So I think it becomes just taking that a level further. Like so you're the map person, and that might be the first entry point. But the most important part about that is to talk to your other colleagues. And I feel like modern GIS, kind of breaks this traditional silo of GIS where you're kind of in your own tools and systems and things like that, and you're the map team, and now you are once again an interoperable part of your technology team, creating really strong value and working directly alongside others in the same languages and processes that they are. And that's a really freeing concept, to be able to go and speak the same language as a, React developer and say, here's what I can bring you. Now, you don't have to be a React expert. You can know parts of it, but it's not to say that you have to know every single bit of it, but you can work together. You can work with a data scientist and say, hey, I can bring you really valuable information, spatial feature engineering, and help you create better models. You can go to a database administrator and say, I can help you ramp up and solve these queries much faster with spatial indices. And I think those are the conversations you should start to look to have. Where can you connect to and solve problems with geospatial data and modern GIS within your organization?
Yeah, I really like that idea. I like the idea of people being entrepreneurial in that way, going out and actively looking for problems, looking for interesting tasks to do. I think it's a brilliant idea. It does require that you have a certain amount of self-confidence, I think. but that you believe in yourself and know that you can actually help these people. It's one thing to say it; it's a whole other thing to deliver on it. So I think that's probably pretty important just to note there. I'm wondering if anybody has read this article that you've written and pushed back on it and said, "No, I don't believe that we're going in that direction."
There has, and I think one thing that I wish I would have made more clear in the article is around, local versus cloud. I tried to call it out, but a lot of the things I'm doing today are in the cloud. I'll be candid about it. So I tend to be in that mindset on a day-to-day basis. But the entire principle of this is that those same technologies and tools you can run locally, you can build these complex stacks. And I've talked to people that do that in their organization, build purely open source from the ground up, and it's incredible the things that they can do. So that's the core principle of all of this, is that you can do that. You can run it on your machines, whether that's on premises or on your local machine or wherever. And I think that's one piece I would have been much more implicit about. I think there's a section that I called out with being cloud native, which is a concept is starting to really gain some traction, thanks to Chris Holmes and Javier, who I mentioned earlier, doing some really great work around GeoParquet and cloud optimized geotiffs. So I think there's but there's like it does say cloud a lot, So I get that. So I think that's maybe something I want to call out, is like, this same architecture works just as easily locally as it does in the cloud, but you don't have to use the cloud. No one's telling you to. I think there's lots of advantages to that, and I talked to those, but there's no one saying you must use cloud. And I think that was an important point I did not highlight enough.
Do you think people feel intimidated by this? Again, like when I was only quarter of the way through your article and I think I'd spotted like 20 different technologies. Do you think people that have been in the industry for a while and are used to doing like maybe using Esri or QGIS, using their desktop programs, they've got a database somewhere in the background, they're delivering web service via a Geo server or an Esri server or something like that. Do you think they look at this and go, "Oh my god, this is way too much. I am intimidated by it."
Oh, of course. I did, and I'll be candid about that, is what there were so many years that I didn't know where to start. I said, "Well, I could jump in, but where do I start? Where do I learn?" And I held back, because I didn't know. So I'll just be candid, that took some time. And eventually, as I said, I'm just gonna start with one thing. And what I loved at the time was building applications. I went JavaScript. I'm gonna learn that. I didn't know if that was right. I said, we're going to see it through. We're going to go and learn it. And it took some time. I took a lot of Udemy courses and practicing and failing. And there was a lot of mistakes along that journey. But eventually I got there, and I started to picked up some of these foundational pieces that, you might in a elementary computer science course, what's an array or a JSON or a dictionary in Python, and then once I learned that, I could easily transfer that over and start saying, okay, I get what this looks like in Python. This makes it a little bit easier, right? And then once I, connected to a database and was calling and restructuring queries from a front end application and sending them back to a database and getting data back, it like all starts to snap together, right? But my number one advice is you need to start somewhere, and if you can find things in the best way to start, I think, is like if there's a problem or something that's difficult, something that could use scale in your current work, whether that's your passion project, your job, whatever, and try to find a way to say, how might I solve this using just one tool, whether that's Python, whether that's a application, whatever that might be. Just start on a very simple level. You're going to hit mistakes. You're going to hit, I'll tell a story about one time I had no clue what a Lambda function was. And I was up for hours trying to figure this thing out because I could not understand what it was doing. And this is it's mildly embarrassing now, but it's like I always tell this story, is like I was trying to figure it out, and I asked a colleague of mine the next day. He's like, "Oh, this is here." I was like, "Are you serious? I spent all this time trying to figure this out." Lambda function. It's not the AWS version, but it's just very simple things, and those that will happen. Feel prepared. And know that it's okay to have those things happen. The other piece is find a community and network, and I think that's one thing that starting to come together. So many people are asking the same questions. Where do I go? What do I do? How do I learn? So many people are learning on the job. There's no right path here, but I think there's a really strong opportunity to bring together some great minds, help people learn, help people grow their careers. and build some ways to learn this so it's a little bit easier. So I think there's a massive opportunity there.
I have to say, I think there's some absolutely brilliant advice. I really hope that people, if they're feeling a bit daunted by this, I hope they rewind that and listen to it again because there's some great advice there. We've been talking a lot about almost trends in the industry, right? We talked about how critical open source is. We talked about how interoperability, it runs the world. It means that we can connect and create different outputs from different places and connect these different technologies. Super important. We talked about cloud native. Yeah, I think you can argue that all of these are current sort of trends in the geospatial world. Another trend in the geospatial world is this low code, no code. And we were just talking about how you got started. You got started by learning how to code. And I can see a ton of advantages to doing that. And the deep understanding that you gain by doing that is incredibly important. But then again, I can also see this trend towards low code, no code. If I was starting out today, would you say, don't worry about it? Low code, no code is on the way. Focus on getting really great at using these tools. Or would you suggest that I go out and learn how to code?
I think that's a really great question. It's something we're very focused on at Cardo today because while we all love SQL, we know there's a steep learning curve to it. There's a lot to learn. It can be incredibly powerful, but we also understand that that's not the core of what everyone wants to learn. I think sort of in a way what we should be doing, with the power of SQL and the things and the energy we're putting into it. Yes, I want people to learn that. And if you want to, I want it to be readily available and easy to learn. But I also completely understand that not everyone wants to do that. So, how can we help you have access to that power and really understand what's happening under the hood, but just access it from a low code environment? I think that's very, very important. Give people ways to start deriving value from it today. And then as they choose to go deeper. So, it's a really tough chicken and egg question. I think low code is on the way, and I think it's very important. And I know that's a problem that we've been at Cardo very interested in solving. So it's something that is very important to us. But in the background of that is the foundational architecture of things like spatial SQL and modern GIS. We also expose that to you. So, for example, we have the ability to create tile sets, in the modern data warehouses like BigQuery, Snowflake, Redshift, and even in PostGIS. But if you want to just flip over and see the SQL that runs that command, you can do that. There's nothing stopping you from doing that. So we want to make it accessible. We're not hiding it behind the scenes and making sure it's there. So in the way, yes, do you think you should learn this? I think it's good to know and know bits and pieces of it. But it's also, like I said, you saw 20 different technologies there. How can we make this faster and easier for more people to use? Because ultimately, what we should all be focused on is solving the problems that come along with this and using the tools to do that. So I think it's a journey. I think where it's important to learn and understand conceptually and go deep where you want to. If that is SQL, if that is Python, if that's data science, like I said, pick your specialization and go deep on those topics. But you don't have to be the jack of all trades.
I don't think there's any right answer here. Like, I appreciate your answer. It's not that, and it's not a critique in any way. It reminded me of what you said about the map. Like, use the map as your starting point. Like, yeah, I did some analysis. Here's the map that you were probably expecting anyway, and then use that to sort of lead into these other things to go a bit deeper with these people. I think that's what people are probably going to do, or hopefully going to do in their own sort of geospatial learning journey, if you want to call it that. Give them some quick wins, make it easy to use the tools. Don't make it like you have to have a PhD in data science to download some software and run a basic analysis. Make it easy. Let them get started. Give them some quick wins. And then I think people will sort of self-select into what they want to learn. At least that would be my approach.
Yeah, I 100% would agree with that. There's no one path, and I think that's a good thing too. So
I totally agree. Matt, I really want to thank you for your time. Thank you very much for writing these articles and posting them on LinkedIn. I get a lot of value out of it. But I'm going to link to this one here, this one about modern GIS, so the people listening to this podcast can track it down and read it for themselves. But is there anywhere else I can send people? Or if someone's listening to this, they want to reach out to you personally, or if they want to connect with you, continue this conversation, where could they go to do that?
yeah, you can reach me on LinkedIn. That's the easiest way. If you go to my website, it's just Forrest FORREST 2 R's .NYC. You can get all my information and connect on LinkedIn, and do my best to respond to messages as quickly as possible. But I usually do them in batches, so just keep that in mind. If I'm a week or two out, that's usually how I respond to them. But definitely connect with me there. We can continue that conversation. I do my best to kind of reach out and kind of carry on these conversations. I think ultimately we solve problems. We're using tools, but at the core of this, we're people doing interesting things, and I think that's always what's most important. And what I appreciate most about all of this is I've gotten to connect with amazing people, much like yourselves, and who are you're having these amazing conversations with great people, and that's always a really important part of all of this.
Thanks again for your time, Matt. I really enjoyed talking with you.
Yeah, same here, Daniel.
Thanks again to Lightbox for sponsoring this podcast episode. If you are in the US or Canada and want to locate your customers and prospects using addresses, geocoding, and property information, or if you're working in real estate, government, telecommunications, insurance, energy, or utilities, check out Lightbox. That's lightboxre.com, and there'll be a link in the show notes of this episode to make it easier for you to find. Thanks, Lightbox. Really appreciate your support. I really hope you enjoyed that episode with Matt Forrest. There'll be links in the show notes to where you can read more of his work, of his articles, and where you can connect with him online. So I agree with Matt. I think this sounds like a modern approach to doing GIS, to working with and analyzing geospatial data. But I also know from experience that the companies that I have worked with, and a lot of the people that I interact with in my day job, are definitely not doing these things. And this might just be because of the industries that I've been working in. But it also might be because change is really hard. And if it's not broken, why would you fix it? Or why would you try to modernize it? And I think probably this is partly my fault. I think I need to rethink my approach to being a geospatial professional. So in this podcast episode, we were talking about the tools and the technologies largely. But I think we need to have a modern approach to our jobs, to our careers, to be advocates for the work that we are doing, to point out that things could be different, to help people understand what else we could do. I know this has been a huge failure in my own career, and my guess is that a lot of us could be better at this, to be almost entrepreneurial in our approach to our jobs, to look for opportunities to do interesting work. And I think the thing about interesting work is it keeps us interested. We develop, and sure, our organization might just benefit from it too. Well, that's it from me. That's it for another episode of the Mapscaping Podcast. Thank you so much for tuning in this week. I really appreciate it. As always, you're more than welcome to reach out to me on social media. You can find me on LinkedIn or on Twitter. And I realize that I have been unstable lately in terms of my publishing cycles. There's just been a lot going on. I apologize for this, and I am working really, really hard to build more consistency around the publishing schedule. I hope that you'll stick with me. Thanks for tuning in this week. I will be back again soon, and we'll talk then. Bye.